Good morning, students. This is Suresh, Maths faculty from DAV High School, SDSTPS, AP Gen Code, NEL2. In this video, we are going to discuss finding square root by division method, square roots of decimals using division method, estimating square roots of non-perfect square numbers, and exercise 6.3 problems related to chapter 6, square roots and cube roots. Let us start. Finding the square root of 625 by using division method. In step 1, place the digit of the given number starting from units place to the left. Place a bar on each pair. That is, first keep the bar on 2, 5 and keep the bar on 6. And the next step, finding the largest number whose square is less than or equal to the first pair or single digit from left. That is 2. Take this number as the divisor and the quotient. Next, 2 2s are 4 and 4 is subtracted from 6. We get 2. Next step, bring down the second pair, that is 25, to the right of the remainder, that is 2. This becomes the new dividend 225. For the next possible divisor, double the quotient, that is 2 into 2, 4, and enter it with a blank on its right. Guess the largest possible digit to fill the blank in such a way that the product of the new divisor and this digit is equal to or less than the new dividend, that is 45. 5s are 225. Next step, by subtracting we get the remainder is 0. Therefore, the final quotient is 25 is the square root. Therefore, the square root of 625 is 25. One more example. Find the square root of 1296. Solution. In step 1, place a bar on each pair. In step 2, finding the largest number whose square is less than or equal to the first pair, that is 12 from left. So 3. Take this number as the divisor and the quotient. Subtract the product of the divisor and quotient, that is 3 into 3, 9 from first pair, that is 12 minus 9, 3. Next step, bring down the second pair, that is 96, to the right of the remainder, that is 3. This becomes the new dividend is 396. For the next possible divisor, double the quotient, that is 3 2s are 6, and write the box on its right. Step 5. Guess the largest possible digit to fill the box in such a way that the product of the new divisor and this digit is equal to or less than the new dividend, that is 66 6 are 396. After subtracting, we get the remainder is 0. Therefore, the final quotient is 36 is the square root of 1296. Therefore, the square root of 1296 is 36. Next topic, square root of decimals. For example, find the square root of 23.04. Solution. In step 1, to find the square root of decimal number, put a bar on the integral part. Place the bar on the decimal part. Next step, 23 lies between 4 square and 5 square. That means 16 and 25. Now we have to take small number 16. That is 4 4s are 16. After subtract, we get 7. In step 3, quotient multiple with 2. 2 4s are 8. And bring down the second pair, that is 0 4, to the right of the remainder, that is 7. This becomes the new dividend is 704, and enter it with a blank on its right. In step 4, guess the largest possible digit to fill the blank in such a way that the product of the new divisor and this digit is equal to or less than the new dividend, that is 88 8 are 704. After subtracting, we get the remainder is 0. Therefore, the final quotient is 4.8 is the square root of 23.04. Therefore, square root of 23.04 is 4.8. Next topic, estimating square roots of non-perfect square numbers. So far, we have learnt the method of finding the square roots of perfect squares. If the numbers are not perfect squares, then we will not be able to find the exact square roots. In all such cases, we at least need to estimate the square root. Let us estimate the value of square root of 125 to the nearest whole number. We know that 11 square less than square root of 125 less than 12 square. That is 11 square means 121 less than square root of 125 less than 12 square means 144. Observe here, 121 is much closer to 125 than 144. So 11 is the estimating square root of 125. Let us start exercise 6.3 problems. Third question. Find the least number that is to be subtracted from 4000 to make it perfect square. Solution. First, we have to find square root of 4000 by using division method. In step 1, place a bar on each pair. Next, we know that 40 lies between 6 square and 7 square. So, we have to take 6 square because it is less than 40. 6 6 are 36. After subtract, we get 4. Next step, quotient multiple with 2. That is 2 6 are 12. Next step, 123 3s are 369. After subtract, we get 31. We find by division method that the remainder is 31. This means if we subtract 31 from 4000, we get a perfect square. Hence, the required least number is 31. Next question, fourth one. Find the length of the side of a square whose area is 4489 square centimeter. Solution. Let the length of the side of a square is x centimeter. Therefore, area of square, that is called side into side. Here side means x centimeter. X into x means x square. But given area of square is 4489 square centimeter. Therefore, x square is equal 4489. Then x is equal, the square will go right side, it becomes root 4489. Next, we have to find square root of 4489 by division method. Observe here. First, place a bar on each pair. That is 44 one bar, 89 one bar. Next, we know that 44 lies between 6 square and 7 square. 6 square means 36, 7 square means 49. So, we have to select the small number. That is 6 6 are 36. After subtract, we get 8. Next step, bring down the second pair, that is 89. This becomes new dividend, that is 889. Next step, quotient multiple with 2, that is 6 2s are 12. Next, 127 7s are 889. After subtract, we get 0. Therefore, 67 is called square root of 4489. That means that is a x. Therefore, length of the side of a square is 67 centimeter. Fifth question. A gardener wishes to plant 8289 plants in the form of a square and found that there were 8 plants left. How many plants were planted in each row? Solution. Number of plants that the garden wishes to plant in a square form is equal 8289 plants. Number of plants left after plantation, that is called 8. Therefore, number of plants were planted in form of a square is equal to 8289 minus 8. After subtract, we get 8281. Next step, let the plants were planted in each row. X plants. Therefore, total number of plants were planted, that is called x into x, that is called x square, because the shape of the garden is square shape. So we have to apply a area of square formula, that is side into side. Next step, x square is equal 8281. That implies x is equal, the square will go right side, it becomes square root 8281. Next we have to find square root of 8281 by using division method. Observe here. First place a bar on each pair, that is 82 bar, 81 bar. Next we know that 82 is lies between 9 square and 10 square, but we have to take small number, that is 9 square. 9 9 ja 81. After subtract we get 1. Next carry the 81. Next step, quotient multiple with 2, that is 9 2s are 18. Next we have to do 181 1 ja 181. After subtract we get 0. Here 91 is called square root of 8281. Therefore, number of plants were planted in each row is equal 91. Next question, sixth one. Find the least perfect square with 4 digits. Solution. Least 4 digit number is 1000. We find square root of 1000 by division method. Observe here, 1000. First place a bar on each pair. 10 bar and 2 zeros bar. 10 is lies between 3 square and 4 square, but we have to take small number 3 square, that is 3 3s are 9. After subtract we get 1. Next bring down 2 zeros, then new dividend is 100. After quotient multiple with 2, you get 6 in the divisor. Next we have to calculate 61 1 ja 61. After subtract we get 39. We get the remainder is 39 and quotient is 31. But 31 square value is 961. 961 is a perfect square, which is not a 4 digit number. Hence 32 square is equal 1024 is the 4 digit number which is the perfect square. Therefore 1024 is the least perfect square with 4 digits. Next question, find the least number which must be added to 6412 to make it a perfect square. Solution. So we have to find square root of 6412. Observe here, first place a bar on each pair. Here 64 is a perfect square, that is 8 square. So 8 8 is 64. Next step, we have to carry the next pair, that is 12. Here quotient is multiple with 2, we get 16. But 160 is a 0. After subtract we get 12. After division we understood 80 square is less than 6412. Next perfect square is 81 square, that is 6561. Hence the number to be added is 6561 minus 6412. After subtract we get 149. Therefore required number is 149 should be added to 6412 to make it a perfect square. Next question, 8th one. Estimate the value of the following numbers to the nearest whole number. In this Roman I will do first question, remaining 2 are homework. Solution for first question. Square root of 97. Here 97 is lies between the perfect squares 81 and 100. Therefore 81 less than 97 less than 100. But 81 we can write 9 square, less than 97 less than 100 we can write 10 square. That implies next we have to find square root of 97. So that take the roots for all numbers, that is square root of 9 square, square root of 97, square root of 10. Here square root of 9 square means square root cancel, we get 9 less than root 97 less than square root of 10 square means square root get cancelled, 10 we get. But 100 is much closer to 97 than 81. Therefore, the approximate value of square root of 97 is 10. Dear children, along with the home assignment, you can copy exercise 6.3 problems in CW. Thank you.